I'm going to present my research work on the topic of flexible urban region representation learning. For urban region representation learning, given the features for each region, we aim to develop a model to transform the regions into low-dimensional embeddings, which can be used to many different tasks. And it is helpful in both the city management side and the people daily life. Currently, there are several limitations exist in flexibility of current method. The first one is current methods heavily depend on mobility data. The second one is they typically rely on a single predefined region information for all downstream tasks. The third one is they do not consider the relevance of input features to specific downstream tasks. In order to solve the second limitation, the current methods directly learn the embeddings of some predefined regions, but we divide this stage into two different stages, which are the grid embedding learning stage and the region embedding generation stage. This allows grid cell embeddings to be combined into region embeddings regardless of the region partitioning method. For the first limitation, we use features from publicly accessible data, and in order to effectively exploit these features, we use different ways to handle them. We use GN for data that can be represented as vector, and we use CNN for images, and we use large language model for textual data. For the third limitation, current methods use all features in region embedding learning stage, but we separate them into both region embedding learning and downstream task learning stages. Here is the overall architecture of our model. We also conduct experiments to evaluate our model on 3 cities across 4 different tasks. The results shows that our model outperforms all baselines, including even this using human mobility data. Then, in order to evaluate the robustness of our cell-based embeddings, we partition the same study area into different sets of regions. Our model also outperforms all baselines across different sets of regions. And thanks for watching.